Okay. Welcome students to the what you call the trigonometry. This is another foundation course or foundation session before you starting 10th class. Okay, right. So now this trigonometry, many often, many a times what you call students feel very tough. You know It is actually, oh my goodness, yaar, itna sara formula hai. How many formulas are there? How to remember? What is the sine, cos, tan? But there is a real beautiful transformation you can make once you understand the basics of the trigonometry. Okay, so that is where we will learn our fundamentals. So what is this fundamentals? What we have to understand in trigonometry, right? So first point, what we need to understand is that what is this trigonometry? The word says trigonometry. See, if I divide this to trigonometry, those tri can say three or a triangle. I say it to be as a triangle, three sides. We can say again, three sides or a triangle. Gono is actually the angle, trigono. And what is the next one? Metry is nothing but measurement. So what are we trying to do? We are trying to build a relationship between angles and the sides of what? Sides of what? Definitely sides of a triangle now, what we are looking at. But why this trigonometry is essential? It is essential to everybody. Suppose just imagine a bird, a bird flying, you can imagine a bird flying. They actually judge the correct angle and they flap their wings and then they move in a particular direction based upon the wind direction. How could they judge it? This is nothing but a trigonometry. In the similar fashion, if I take this, the pilots, how could they actually judge their position? Their angular positions. They will explain where they are, and even in the satellites, when the satellite is moving in the orbit, definitely everywhere you see. Now I'm actually facing this, laptop and trying to explain the laptop screen. What I am actually adjusting here, that is, there is also an angle, right? So there is a triangle, there is an angle, there are sides which needs to be measured. So for engineers, for surveyors, for every other, if suppose if I want to measure the height of the building, then what? If I want to measure the position of the sun with respect to the shadow, then that is also one of the trigonometric application. Okay. Now, the very important triangle that we need to understand in the trigonometry is the right angled triangle. That is RAT, right angled triangle. How does a right angled triangle look like? So I position two things here. This is the right angle triangle. How do I say right angle triangle? One angle is nothing but 90 degrees. One angle is how much? 90 degrees. That is the reason it is known as right angle triangle. And I name the vertices A, B, C. This naming of the vertices in the anti-clockwise direction, I name the vertices here, that is known as 90, or vertices here. ABC is my triangle. So angle B is how much? Is 90 degrees. Now I pick up angle C, assuming it is something called theta. So this is theta. Okay. That is what? That is known as a theta. So that is a theta where we are looking at. Let me actually draw it in another angle. This is known as theta. Okay. One is 90 degrees. Another one is theta. So this becomes the right angled triangle. Now, the other very important thing which is here to understand is that once we know the angles here, now this is the theta. This is the theta we are written, and this is A, B, and C. There are three sides. When we said tri, that means we said tri means three, triangle, the three sides. The angle which is opposite to the theta, the side which is opposite to the theta is known as opposite side. This is first very important. The side which is adjacent to the, the adjacent to the angle theta is known as adjacent side. And the side which is opposite to the high right angle, that is 90 degrees, it is known as hypotenuse. Hypotenuse is supposed to be the longest side in this triangle. This is what? Longest side in the triangle. So this is the basic of, the trigonometry. We have started with what is trigonometry and where it is applied. Do we have any fears? Yes, we have fears. Then what is the important triangle we should look at? Right angle triangle. If this is understood thoroughly, I think, the trigonometry is like, it will become an easy tool for us. Now, let us go forward and understand what are the three, trigonometric ratios that actually that we will work on. The sine, if I say sine, actually it is written as SINE, sine. Or rather, I should write it in a different manner. It is something like this. If I say it is sine, we write it as small as sin. And cosine, we write it as cos. And tangent, we write it as tan. Okay. These are the three trigonometric ratios. What are they? Trigonometric. Trigonometric ratios. Let me write it again. Trigonometric ratios. We call this as trigonometric. That means they build the, what you call, relation between angle and the side. So then what is our trigonometric ratio? See, we already have a triangle, or rather, we already have drawn a right angle triangle like this. And this is theta, and this is opposite side, this is adjacent side, and this is a hypotenuse side. Now we write by definition, sine theta is opposite by hypotenuse. Cos theta is adjacent side by hypotenuse. Tan theta is opposite by adjacent. Now, how do we remember? See, this is the memory technique. SOH, SOH-CAH-TOA. SOH-CAH-TOA. Something like that. This says what? Sin theta is equal to opposite by hypotenuse. This says what? Cos theta is equal to adjacent by hypotenuse. This says what? Tan theta is equal to opposite by adjacent side. These are the very important aspects of the trigonometry. Okay. There are formulas, identities, which we will come to know. So now the real life applications. See, as I already told you, that means, an engineer, a surveyor, a pilot, how they find out their location, how they find out the height of the tower, how they find out the height of the mountains. Many things are there. The answer itself is known as trigonometry. Now, the very small, problem, there is a flagpole. Suppose, say, if I say there is a flagpole like this, this is a flagpole. And I think you are better able to understand what I am trying to show you. This is a flagpole. And of course, the flagpole has to be constructed on the ground. And this is the ground. And, during our Independence Day and all, what do? We actually hoist the flag, right? We actually hoist the Indian flag, right? We hoist the Indian flag. See, I'm not drawing it to the color. Please, with due respect to our national anthem, national flag, please don't take me wrong. This is for only our understanding. Suppose, say, this is a flag post, and let me remove this because, this should not actually hinder your study. And this is my point, the topmost point of the pole. Okay, and just imagine this is where the flag is hoisted. And myself, where I am standing here at some place away from the flag post, center of the flag post, from here to here. This is the distance. Let me draw it with another color, and so that you can actually better make it. This is where my distance is coming, and this is one measurement. This is one measurement. Now, from this place, if I am trying to look at the flag post, flag post top, and I am saluting, and what if I know the angle at which I am looking at the pole, what is the height of the pole? This is the height of the pole. Generally, there will be some things called height of the pole will be fixed. We will know the height of the pole, and I know at what distance I'm standing from the ground, a foot of the pole, and I'm here. What is the angle at which I'm looking at the flag which is hoisted? Such type of this is one of the what you call one of the applications of the trigonometry. And suppose say you have seen a bow and arrow, right? A bow and arrow, the archer, he tries to shoot on the aim, right? He doesn't, when the point at which he looks at, the goal at which he looks at, the aim at which he keeps at, that is a calculation. By practice, he will be able to know exactly, he can able to judge the angle at which the bow and arrow to be hold up. Then straight to the target, he will be succeeded. That also involves the trigonometry. So these are the basics of the trigonometry. Now I think you have laid down, I have laid down certain fundamentals into this particular trigonometry. But there is one theorem which you might have been introduced in your classwork, right? In your 8th class itself, if I am right, when you say right angle triangle, there is one theorem which needs to be reflected, or which will reflect in your mind. That is known as what? The famous Pythagoras theorem, right? This Pythagoras theorem revolves around the three sides of the triangle. Which sides? 1, 2, and 3. Three sides of the triangle, this Pythagoras theorem holds good. This Pythagoras theorem is very, very important in our particular trigonometry to understand. Okay, with this short introduction about the trigonometric basics, trigonometric fundamentals, I feel you are ready. Yes, I am ready. Now our transformation is this. Now let us actually rub this up, and we are no longer looking at this particular thing, but we can now say confidently that yes, I am ready for the trigonometry in the 10th class. But be very cautious. The daily practice is what is important, consistency is important, and of course, learning from the mistakes that is where you will be a good learner, and you can score good marks. What you expect here in the numerator out of the 100? Do you expect 50 or chalega? No. You expect 60? No. 70? No. 80? No. Maybe at 90 or 95. Then definitely you'll reach your heights. Okay. With these few words, I take leave. I'm your CV sir, and we meet you again. This is your channel, Maths Champions Arena. Subscribe to the channel for more fundamentals like that. I will solve the more problems for you, and I will give you the tips rather than directly straightforward solving. I will try to do some things with you. Okay, bye, see you.